this lesson, you will learn how to manually combine attribute instances and some of the possible combinatorial methods. Up until this point in your test case design, you have created individual attributes and the instances which reflect the variation of these attributes. Using combinatorics, we will begin to combine these attributes to reflect the actual data combinations needed to test the requirement. There are several methods for combining the data. The methods supported by Tosca include all combinations, orthogonal, pairwise, and linear expansion. All combinations is a method which ensures that all possible instance combinations are taken into account for testing. This method of combination results in the highest number of test cases. Let's look at an example. Here you can see 3 attributes with 3 instances each. All possible combinations of this data would result in 27 possible data combinations. The orthogonal method will result in the lowest possible number of combinations. Each instance value must be used once, but that is the only requirement for the combinations. Using our last example, 3 attributes with 3 instances each will result in only 3 combinations. The highest number of instances on one of the attributes being combined will be the number of combinations. If one of the attributes has more instances than another, then the instance values of the attribute with fewer instances will be repeated until each of the instances with a higher quantity are used. The pairwise method combines each pair of possible value combinations for 2 attributes. We will not focus on this method. Finally, linear expansion is the method recommended by Tricentis. This method defines a straight-through or happy path. The first combination will use all straight-through instances. This could be considered a smoke test. As mentioned in previous lessons, the straight-through should be the test case with the highest risk if it were to fail because it is frequently used and has the fewest dependencies. All subsequent combinations switch out one straight-through instance for a non-straight-through instance. All non-straight-through instances are combined individually in this way until all instances are tested at least once. This methodology provides for a clear test focus in each combination, because once the straight-through is tested, each of the combinations created using this methodology will have only one instance value which is different from the straight-through instances. Here, you can see the difference between the methods as additional instances are added for attributes. All combination grows quite quickly and results in the highest number of test cases, with a long and complex test sheet. This could result in a very high number of test cases, which means longer time in execution. This may not be the most efficient testing method. Orthogonal has the least number of test cases because it generates the minimum number of test cases. This will result in the shortest possible execution time, but the test cases have no clear focus in case of failure and will result in a longer time debugging. Finally, linear expansion results in a moderate number of test cases. For each additional instance, an additional test case is created. This is because each instance has one test case in which it is the primary test focus. When would I use each method? Well, this largely depends on your project, its requirements, the level of specification and granularity of these requirements, as well as any legal or regulatory specifications. For example, in some industries, you may be required to test all combinations for certain requirements. Tricentis recommends linear expansion where possible or practical, but of course this depends on your project. Now that we have defined the combinatorial methods, let's learn how to build them in Tosca. We will be using linear expansion. These combinations can be generated automatically and manually. For the time being, you will only use manual combination. In later lessons, you will learn how to combine automatically. In Tosca, these combinations are called instances and are represented in columns. Next to each attribute on the test sheet, you can then select the relevant instance from a drop-down box. When using linear expansion, the first generated instance will be the straight-through and will have all straight-through instances. These instances have the same properties as those we have created so far, meaning you can define the character and position. With the test sheet in focus, you can see all generated instance columns. In each subsequent instance, you should switch out one straight-through for a non-straight-through instance. In a real project, remember that some adjusting may be necessary, as this methodology does not take into account dependencies or relationships between values and attributes in a business context. These instances now represent the test cases which are needed to test the associated requirement, and the values can be used in the test case section using the template concept. In addition to combination on the test sheet level, instances can also be combined on an attribute level. This means creating instance combinations on lower levels. For example, one of my attributes may be credit card information. Below this attribute, I have details concerning this information. If I focus on the attribute, I can create credit card instances. Each one will contain the information which I select. Then on the test sheet level, I will only need to select the name of the combined information instance, and the associated values for that instance will be automatically populated. This serves to make combining easier and more accurate. You can see whether an attribute has been combined at attribute level because their values are highlighted in light yellow at these levels. You can organize your instances by right-clicking on the test sheet or clicking on Optimize Instances from the ribbon and selecting Arrange Instances. This will group them by position and character. First, the straight-through instance, followed by valid inner instances, invalid instances, boundary instances, and finally, invalid boundary instances. You can also merge instance duplicates, both in the ribbon and in the context menu, which will find all duplicate instances. In other words, instances which are identical and remove all but one. You can see how many instances are on the test sheet level by hovering your mouse over the test sheet icon in the working pane. Remember, in order to see the instance columns on a certain level, you must be focused on that particular level, whether that be test sheet level or attribute level. Additionally, you may come across the problem in the test case design section that you create instances but then cannot see them. Try pressing F9, which is the shortcut for hiding and revealing instances in the test case design section. This exists because with large, complex test sheets, it is sometimes easier to get an overall view of the data by hiding the instance rows.